morning or afternoon, everyone. I'm happy to see everyone here, and welcome to Exploring the Dark Arts on macOS. So my name is Brandon Dalton, and I focus on macOS threats here at Red Canary. Adam, how do we get the slide to it? Oh, here we go. Okay. Sorry, slight difficulty there. So my name is Brandon Dalton. I'm a senior threat researcher here at Red Canary. I focus on macOS threats, and I'm also the author of our Mac Monitor. So,
Remember, put your.
oh, there you go. Okay. So the agenda. So how can we get it? Endpoint security is a data source for us defenders, a feature overview, and then we're going to go into some pretty advanced demos that I think everyone will really enjoy. So the requirements here are pretty straightforward. All you need is macOS 13.1. Apple Silicon or Intel works as needed. And then you do need to give full disk access to the security extension. This is a requirement of the API. And so what does this look like? Well, you can install via GitHub or with Homebrew using one line. The installer package on GitHub will just be more of an interactive install. So you'll download the installer and then kind of click through the different options there. And this is what that will look like. And then for both options, you will still need to allow the security extension, shown in option 1 there, as well as give the security extension full disk access. And then the uninstall process is also very easy. So from the Finder, be sure to not do this from the dock. You can delete the application just at the top level. That will prompt macOS to also remove the security extension. And this is important because the security extension is kind of the piece that monitors the macOS system events. Or you could use the command line, and this will actually hit the endpoint security API or the system extension API to uninstall that system extension for you. So what problems does this solve? We actually set out to make this thing to solve a lot of problems that we were experiencing here at Red Canary, and then decided to release it to the public so that others could also glean some value out of it. So this is kind of a 100-foot view of the Red Canary detection pipeline. And you'll see it's a little bit complicated, right? So we have an EDR sensor that is installed on a macOS endpoint. It will stream telemetry to S3 buckets. It will then be processed by the Red Canary detection engine as well as our analysts, and events come out that way, as well as that's how we're able to glean insight into the raw EDR data provided by our partners. So the issue with this is it just took a really long time, right? So we ran tests, waited for sensor uploaded, waited for EDR to forward that telemetry to Red Canary. Then we had to wait for Red Canary ingest and to sync down. So essentially what we wanted was this telemetry a lot faster and higher resolution. So this is kind of what Mac Monitor looks like in its state right now. We have a lot of really awesome features that we'll walk through today, as well as kind of presenting it to the user in as contained of an experience as possible. So we don't want any external dependencies or anything like that. People should be able to just install this thing and get up and going. So some of our core features are the graphical user interface. So this is something that we spent a lot of time on, ensuring that the UI is both intuitive, but also provides the most data at the right time to users. So right now we have 41 endpoint security events that are collected, and we'll talk a little bit more about these events in a little bit. We also fully cover, well, not fully, we partially cover the path muting API and implement artifact filtering. So this really enables you as an analyst to kind of cut through the noise and also save your computer from processing an insane amount of events. That's what the path muting is for. Detailed event backs with jumpable subtrees. So this is really important as well because it's great that you have these events, right, that are delivered by endpoint security, but a lot of times they don't contain everything that you're interested in. We as Red Canary have to go out and enrich those events as well. We also offer correlation and performant logging with core data. So that's how the Mac Monitor program actually stores those events in memory. And of course, you can export those events to share your results with other researchers as well. So let's talk about system events now. So Mac system events are pretty interesting. There is not a one-to-one correlation between these and other platforms. So let's kind of walk through this at a little bit of a slower level. So Mac Monitor only receives events that were subscribed to. Not all events are subscribed by default. You're free to modify your event subscriptions on the fly. And so what do I really mean by this? Well, if we take a look at the left here, You'll notice that there's some different telemetry classes that we cover with MacMonitor. So some of the top ones that you'll notice are like process, file metadata, file system, stuff like that. And then more interestingly, in macOS Sonoma, Apple started adding authorization, XPC, and Open Directory eventing as well. And then if we look at the chart below that, or a table below that, you'll notice that not all these events are subscribed by default, right? So for example, exec events are, but notify signal events. So when a process signals something else, those are not subscribed by default just because they're a little bit noisy. I didn't have enough of an opportunity yet to kind of apply a really nice mute set to that. So endpoint security as a data source, right? So there's 146 available events in macOS 14. That's fantastic. However, that's a lot of work for defenders to go out and implement all 146 events. So distilling through R&D, you can kind of model the most high impact events for your environment. So in MacMonitor, for example, we modeled 41 of these on macOS Sonoma, and 27 are subscribed by default. So what are we trying to get at here? What I'm trying to communicate is essentially the number of events covered by any given EDR agent is not a great representation of coverage. Instead, you should be looking at those telemetry classes that we show on our overview on the GitHub page. So let's go through the primary user interface now. So MacMonitor is a pretty large application with a lot of different functionality baked in. So let's walk through it at a little bit slower pace. So at the top there, you have a command bar where you can start, stop, filter, search through events, also get rid of that mini chart if you don't want to see it. The next table below that is for non-filtered system activity. So any event that you're subscribed to that is not filtered or muted will appear there. And directly below that, you'll see everything related to process activity. And the reason why that's so important is because process activity is kind of that first class telemetry citizen at Red Canary. And bringing that to the forefront is kind of one of the most important things for us. Now let's talk about the macOS menu bar as well, because we include a lot of really awesome options in here for you to utilize. So the settings enables you to kind of customize your experience as much as possible. And there you can kind of go through and modify your subscriptions or add new paths to mute, or even look at if your system integrity protection level is degraded in some way. You can also just remove the process execute tables or the unified tables using the view menu. You can, of course, just uninstall the security extension using the menu bar if you just want to get rid of that piece, which logs telemetry. You can export the telemetry collected in JSON form. And of course, you can email us if you need some help. So now let's talk about event subscriptions. So in endpoint security, event subscriptions essentially tell macOS we should inform this client of an event that happens. So the way this works actually in practice is there's an initiating process, and this initiating process performs some action. If that some action is subscribed, for example, authorization judgment, then MacMonitor will be notified of that activity. And so from this UI, you have the ability to directly jump to the Apple Dev Docs. And not everything is fully documented on the website just yet for the beta releases. Also, you can unsubscribe from events, and you can reset and resubscribe to whatever events you'd like. So now path muting at the endpoint security level. This is kind of crazy. Apple put a lot of work into this. And it's not so clear how to bring it out to a UI perspective, right? These are a lot of really advanced features, and it's kind of hard to present this information to the user in a nice way. So what we did in MacMonitor was instead come up with 4 different types of mute classes and kind of color them a code, give them a color code, and then essentially give users a way to easily add these different mute types into the UI. So a little trick here to remember is essentially like the target is event specific, and the initiating process is process specific, the initiating literal there. And now if we go into some more information about the path muting stuff, we have individual path muting controls, so you can change your muting type. So this would include things like if you want to hit specific types of events. So for example, this top path here, user libexec sysmod, this is only being muted for proc check events. And the reason why is because proc check is very noisy for that path. But for example, I don't want to mute that for process execute events. So we have that granular level of activity there to kind of apply muting. And when you want to apply a specific path muting parameter using the UI, this is what you're presented with. So you'll be given the option to kind of choose those classes, those 4 different types of muting classes, either the initiating or the prefix, and then based on the target or that initiating process. And you can specify the events you would like muted there as well. And then, of course, you have the option to export the mute set. And this is interesting because it allows researchers to share their mute sets across each other. And one feature that we haven't built in just yet is importing a mute set. So, if you share a mute set with someone else, you couldn't necessarily import that directly back into MacMonitor, but that's a feature in the future that we're thinking about adding. And then in your preferences, you have the ability to kind of customize things as much as possible, at least that we've thought of initially. So if there's any more ideas here, we would love to hear them. But essentially, it enables you to customize kind of the persistent behavior of the application. So if it asks if you would like to confirm to quit or clear, or even if you would like certain options to appear in your context menus. And in the advanced settings here you'll see stuff like sensor ID, as well as your system integrity protection status level. This is just helpful pieces of information as a security researcher. And lastly here, let's kind of go through some of the unique aspects of the table view itself. So if a process is running as root, you'll notice a specific symbol that's placed there. Same thing if processes are ad hoc signed, or if the signing ID is not known. And if the signer is completely unsigned, then you will see something like this as well. But we also include file quarantine awareness. So we're actually checking each app's info plist and making sure that it's file quarantine aware. And if it is, then we're going to place this symbol here because the telemetry is treated a little bit differently. So now here's a sample event. This is for process execution events. And some key things that I'd like to point out here are correlation and grouping. So these help guide your analysis. And we'll walk through this a little bit in the demo too. And then code signing certificate chains, which are not included with endpoint security, as well as our process tree, which includes fork and exec events. So beyond endpoint security now, so what do we include that endpoint security doesn't explicitly tell us? So things like, was launch services involved? Is this the first group in the process? Is it the leader? Is the process file quarantine aware? We also decode user IDs, gleaming insight into the signer ID type. So if it's an app store app, if it's a developer ID, that kind of thing. And we also just mentioned that certificate chain as well. And one more example, and another type of event would be background task management items. So for these, we're going to pull the full plist, and this is really helpful for analysis as well. And, if the plist was to be quickly deleted or something like that. So now I'm new to macOS. Where should I start? The telemetry is pretty confusing. I need to take a look at some Mac system events for the first time. What should I do? Well, I would suggest first taking a look at some of these good resources. So Atomic Red Team enables defenders to kind of emulate high-level MITRE attack techniques on their endpoint. The POSIX Atomic Test Harness suite takes things a little bit at a deeper level. And we have 2 tests available for macOS on that end of the spectrum, as well as a suite for Linux. And then take a look at the Mythic agents as well. So this is a fantastic C2 framework for macOS, not specifically just for macOS, but really it shines in the Mac space. So a quick example of POSIX atomic test harnesses would be something like this. So you want to test the OSIKit framework, right? You don't want to write any code. You just want to quickly simulate this activity and see if you have resolution for it. Well, if you run through this using the command at the top, this is some of the telemetry you would be presented with as an output. And so then you as a defender would take this output and compare it against telemetry produced by your EDR agents or MacMonitor, for example. And so now let's get a little bit more into some interesting items here. So let's talk about the Poseidon Go agent, because this is what we're going to demo today. So we're going to demo compromising a macOS endpoint using the Mythic Go agent, and then kind of looking at the telemetry produced and seeing like, okay, this is kind of cool. What can we use to glean insight into what's actually going on behind the scenes here? So some OPSEC considerations for Poseidon are as follows. Gatekeeper is a problem because generally speaking, an adversary is not going to sign Poseidon with a developer certificate unless they were able to fraudulently obtain one, in which case they don't care about that cert being revoked. TCC, transparency, consent, and control. This restricts process access to sensitive locations on disk for macOS. So think of something like your desktop or your downloads folder. And also non-system software Swift. So if you wanted to like compile Swift code on host, you couldn't do it with Poseidon. And something that I want to talk about with this would be something like keyloggers. And so some capabilities that we're going to go through today are execution, persistence, credential access, and command and control. So what does it look like? What does like macOS do in response to some of these things? Well, if you were to just try to execute the binary directly, like we said, Gatekeeper would present a problem there. But then you're pretty much good to go as the code flow goes. So some things we'll be demoing here are JavaScript for automation, also GUI input capture, launch daemons, screen capture, and keylogging. All right, so what's all the fuss about? It's time for some demos. So I'm thinking that people will really enjoy this demo. And I think it'll be pretty fun to go through. Okay, so on the left here, we see a macOS 13 VM. It's pulled up to a website called Welcome to iCloud Pro. So Red Canary is introducing a new Apple product today called iCloud Pro, specifically for developer use. So the whole idea here is someone would be phished with a link to a website that looks similar to this. We're then going to utilize the AppleScript URL handler to materialize a package installer on disk using the Ruby interpreter. And then that is going to initiate a whole bunch of adversarial activity that we're going to look at in macmonitor. And on the right-hand side, you see that Mythic C2 server. So the first thing we'll do is we'll start up macmonitor. And the next thing we'll do here is we're going to want to try out this exclusive developer preview. So we're going to click the link. And what we're presented with is a new script in the script editor, and it contains some installation instructions. So click accept from the developer and click to new script, and then click the sideways triangle to install. So we're going to go ahead and do that. And the installer pops up right there. Say hello world is installed as a launch agent. That's not necessarily important. Okay. So we're going to quickly go through a series of activity produced here, and then we're going to get our hands on keyboard and start doing some interesting actions. So the first thing I want to kind of put everyone's attention to we can find it here is we're going to be looking for the post install. So using our search feature there, we can quickly find that. And pulling this up, what you'll see is this installer package, installer helper, install helper.pkg is installing a post install script. And then from that post install script, you see Mythic kind of spawned out of that, or Poseidon spawned out of that. And if we go back here, if we look at the launch control event here, we'll see a few different interesting things happen. So if we take a look at our process group, this is everything that post install kind of did as part of the same process group. So you'll notice curl occurred. So this is the adversary utilizing the curl command to download Poseidon on disk. This enables you to not have the quarantine attribute applied, initiating a gatekeeper check. The adversary then makes Poseidon executable. The adversary then loads the launch daemon plist. And what makes this interesting as well is we can kind of go through and look at that launch daemon that was created, and you'll see that right here. And if we take a look at the property list, you'll notice that, hey, this was installed to the user local bin directory under Poseidon Mythic Agent. All right, that's great. And let's start up the trace again, and let's get our hands on keyboard. So the first thing we're going to want to do here, just to kind of demo some things, is we're going to get the user's password. So first we have to switch our working directory. And this part might take a little while, so just bear with me here. Doing live demos is always fun. But what's nice is you'll kind of see the telemetry stream in as this occurs. Okay, so now we have our password prompt. So the user entered the password, and that will be returned in plain text here. As we can see, well, I forgot an O, but it should have been root. The next thing that the user or the adversary is going to do is start up a keylogger. And this is going to be done through Atomic Red Team. And so what we're going to do is just run through some of these commands and then show the telemetry output afterwards. Okay, so Atomic Red Team is now being downloaded. Okay, and it looks like the keylogger has spawned. And this is using Swift Spy from Justin Bowie as well. Okay, so the HID manager was created. And the last thing for us to do as the operator is just do screen capture. And then we're going to take a look at all the telemetry in Mac Monitor. Okay, well, perfect. So now the last thing that we're going to do here is we're going to stop our trace, and we're going to take a look at all the different types of activity that occurred here. So the first thing that we're going to do is take a look at Poseidon actually, interactively gating someone's password. So something that's interesting about that is it's going to emit a HID event in terms of IOKit open. So if we go back through here and if we filter out all of our events, and if we're just going to take a look at IOKit open here. Okay. And here, that one is. Perfect. Okay. So you can see that the script editor spawned IO HID param user client. So essentially that asks for user input from the user. And the next thing that we can see here is also it was produced here. And lastly, for the keylogger, it was produced here. And we kind of highlight this to kind of bring it to the user's frontal view, saying like, oh, human interface device was now attached using this process. Okay. And for screen capture, that's the one last piece of telemetry that you're really not going to be able to glean a great deal of insight with using endpoint security. Instead, what you're going to be really having to utilize there is the on-disk SQLite databases and the console. Okay. And so that was our quick demo. And now let's talk about some detection analytics. So this is actually pretty straightforward, except you're not going to be gaining a whole great deal of insight into a lot of these different items. So for the key logging, we have the IOKit open event, which tags us back to the original process. So that's good. But for screen capture, we don't have any direct endpoint security events that enable us as a defender to kind of glean insight into that. For launch items, we have our background task management events, although these were buggy in earlier versions of macOS, but there do exist heuristics at the write and rename levels to kind of glean insight into that as well. For GUI input capture, we talked about exec and mmap events. So the memory mapping event will be if any OSA component is mapped into memory as well. And we also mentioned the IOKit open event for that GUI input capture. Okay, and now we're also going to start a poll here. So what features is everyone the most excited about in a future release of Mac Monitor? So some things that top of mind for me are network telemetry in the form of a network extension, headless operation, so forward your events to S3, the ability to add your own detectors as code. So you're given all these different events, right? You can now kind of detect or write your own detectors. And some key takeaways here are that it's pretty easy to install. You can use Homebrew. The use cases are pretty wide as well. So system troubleshooting. So one thing that I find a really great use case for this is while I'm developing in-memory offensive operation tooling, this is really helpful to kind of see when things exit improperly or when things are improperly related from a heuristical level. So things like, are you running as root, file quarantine enabled, your exit codes, Active Directory error decoding, library loading. Also as a security research tool. So we used this to help us understand what was going on at the gatekeeper level when we found our gatekeeper bypass. And of course, you can also use this to troubleshoot persistence items with legit software installations. Okay, and lastly, are there any questions that we can go through before we kind of end off everything here? It looks like that was it. But if anyone has any questions, please throw them in the chat.
Yeah, I'll give it a few minutes here. I know there were a few in the Q&A section. I don't know if you want to answer those or not.
There is no license cost for Mac Monitor. It's a free install. And is that the only one, Adam?
Another one just came in. Can this play nice with Elastic Waza?
Yeah, so it is working nicely with other security extensions. So, you could install this alongside Defender as well, any other security product. And what's nice about this is you can kind of get insight into what these security products are doing, right? So one fun thing you can see is like when it's writing events back out to disk, or when it might be uploading telemetry to their Defender S3 bucket, something like that.
Cool. I think that might be all.
Awesome. Well, thank you so much, everyone. Really appreciate the opportunity to share some of our awesome work here. And if there are any questions in the future, please do reach out to us using the GitHub resources, and we'll get back to you.
Perfect. Thanks, everyone. Have a great day.